Good morning, dear students. I am Dr. Batmi Srinivas, Professor of Chemistry in St. Peter's Engineering College. Today, we will discuss about the effects of doping on conductance. What is the topic today? Effects of doping. On conductance. Effects of doping on conductance. This is the topic. This is the last topic in second unit. Okay. In the last video, what we have discussed? What did I explain? Types of materials. What are the materials? Semiconductors, conductors, insulators, and band structure. Band theory. Example what we have taken? Lithium as a material, that is a lithium solid. 1s band, 2s band, 2p band. Okay, that is about the lithium bands in the last class. So the band between that, in the types of materials, valence band and conduction band we have discussed. The large gap between the valence band and conduction band, that gap is known as what? Fermi gap. The Fermi gap is very large in where? In insulators and very less in semiconductors, and there is no Fermi gap between the valence band and conduction band. In where? In metals. That is we have seen large gap, little gap, and no gap. This is the insulators, semiconductors, and conductors. This theory means the story of this one already we discussed in the last video. Okay, today we have seen what is the topic? Effects of doping on conductance. So semiconductors are doping to generated either surplus or deficiency. So what is the doping? Surplus electrons or deficiency electrons. What is the surplus electrons? Surplus means excess. Excess. And deficiency. Deficiency. Deficiency electrons. Deficiency electrons. Where in valency electrons. Doping allows researchers to exploit the properties sets of elements. Properties of sets of elements referred to as dopants to modulate the conductivity of semiconductors. So doping allows researchers to exploit the properties of sets of elements referred to as dopants to modulate the conductivity of a semiconductor. There are two types of dopants are there: N-type dopant and P-type dopants. N-type dopant and two types. There are how many dopants are there? Two types. There are the N-type dopant and two type dopants. N-type dopant acts as an electron donor. What is the two types of dopants? N-type and P-type. N-type dopant and P-type dopant. So N-type dopants act as electron donors. Electron donors mean there is a surplus of electrons. Mean they are having the surplus of electrons. And P-type acceptors. P-type dopants act as electron acceptors. Electron acceptors. acceptors mean deficient. deficiency, electron acceptors. So there are the two types. Okay. When combining n-type and p-type conductors create system which have useful application in modern electronics. In modern electrons, when combining of n-type and p-type, so very useful in modern electronics. So this is a more useful. That is the reason we have to know what is the effect. So two types are there, n-type, p-type. There is the excess electron means surface electron, that is the electron donor, and there is the deficiency mean that is the acceptor electron. The acceptor the p-type and donor is the n-type. There are the two types of dopants. Okay. So first, so what is doping? What is doping? Okay. What is doping mean? The addition of small quantity of an element, impurity, small quantity. For example, one crystal is there, a big crystal. So this is the big crystal. So here we add the small quantity of impurity. This is the impurity. The addition of a small quantity of an element or an impurity, element is nothing but impurity, to a pure semiconductor. This is the pure semiconductor. It is an impurity of another element. It's one element, another element, other element. So other element is a small quantity. So it is act as an impurity. It is a semiconductor. It is a semiconductor crystals. Well, what is doping? The addition of small quantities of an element or impurity to a pure semiconductor to change its electrical conductivity characteristics. So this character will change. When we add this one, that changes the character. So before this other character, when add this one, impurity will change the character. Understand? So what is that? The addition of small quantity of impurity to a pure semiconductor to change its complete property, complete electrical conductivity is changed. So there are the two types dopings. What are that? N-type doping and p-type dopings. How many types? N-type doping and p-type doping. N-type doping and p-type. Okay, so let's look the N-type semiconductors. Okay, now this is about the doping. Small quantity of this is a crystal block. When you add a small impurity to the crystal block, then the crystal block character, the conductivity is completely changed. Okay, now N-type semiconductors will look. N-type semiconductors. So this is important topic. So be careful. So we have seen what is that N-type semiconductors, P-type semiconductors. There are the two types. Okay, now that N-type semiconductor means a doped semiconductors in which conduction is due to the movement of additional electron. What is that? N-type semiconductor? The movement of electron. What electron? Additional electron. This is in N-type. Whereas in P-type, what is there? doped semiconductors in which the conduction is due to the movement positively charged holes. What is that? Positively charged. Positively charged holes. P-type conductors, just you have to remember. N-type conductors, the movement of additional electron. The movement of additional electron. Whereas in p-type semiconductor, a doped semiconductor is what? Positively charged holes. The positively charged holes. We have to remember. The two things are very, very important. We have to remember. N-type, additional electron. Just mean N-type means surplus of electron. Mean donate it. Mean additional extra electron will come. When impurity mean extra electron. And p-type mean so electron deficient. So positively charged holes. Positively charged holes are there. Okay. Now we will look the N-type semiconductors. That is first we have to look the. I will draw the diagram. So please draw it. The diagram is very, very important. Please write down. Okay. So N-type semiconductors, we have to take the silicon or germanium. Okay. Crystals of silicon or germanium. Silicon or germanium. So I will draw the silicon crystals. Okay. Silicon crystal. This is the silicon. So silicon, 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 silicon. So silicon having the 4 electrons. 1, 2, 3, 4. So 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Here, this is the silicon crystal. What is that? Silicon crystal. Silicon crystal. In this, we had the small impurity. That is where this is the small impurity. That is the small impurity. Either phosphorus or arsenic. Small impurity. Okay. Now, this is the crystal block of crystalline. Just we added water, some impurity. Okay. So, by looking the diagram, what we know? This is the crystal. Just added the silicon crystal and added a small amount of another element. So look, when doping a semiconductor, such as silicon or or germanium. This is belong to fourth group of the periodic table. We know the silicon, carbon, silicon, germanium, like that. So it is doped with phosphorus or arsenic. Phosphorus or arsenic. It is a pentavalent. Actually, this is fourth group element having the valence is the 4. And this is the fifth group and pentavalent. Valence is 5. Mean 5 electrons are there. Pentavalent. That is the difference between this one and this one. So mean all the silicons are sharing a pair of electrons with another silicon atoms. Okay? And we have removed one silicon crystal and added the unphosphorus. Mean doped with the phosphorus or arsenic, a pentavalent N-type dopant from group 5th in the periodic table. The dopant behave as an electron donor because here what an electron excess pentavalent means 4 are shared with the silicon. One from this silicon, one from this silicon, and one from this silicon, one from this silicon. And excess electrons. This is an excess electron. Pentavalent means 5 are there. Excess electron. The dopant behave as an electron donor. This dopant electron donor means one electron is extra electron is there. So it is ready to donate. When this occurs in an atom, dopant replaces an atom of silicon in the lattice and therefore an extra valence electron is introduced in the structure. What? So when added to the crystal pentavalent and when we added this one electron, the extra electron is act as a donor. Extra valence electron. That is the fifth valence electron phosphorus creates surplus of electrons. What? It creates the surplus of electrons. Surplus of electrons. So before addition, all silicon molecules are bonded. Same. The little gap is there. In that gap, when we add the one impurity, that is one other element like phosphorus. Phosphorus is having the 5 electrons, 4 are shared with the side silicon and excess electrons are moving. So that is N-type semiconductor. Mean the excess of electrons moving from Fermi gap, the valence band and conduction band. What is that? Valence band and conduction band. Valence band to conduction band. These electrons are moving. The electrons are moving from valence band to conduction band. That is the N types of semiconductor. When just few atoms of the dopants replace the few atoms and add the impurity in the lattice of the. So an N type semiconductor is created. This is the N type. The newly created semiconductors are better, able to conduct current than the pure semiconductors. So before addition, so some conductivity is there, X conductivity. And when addition after that, it is a 2x or 3x mean the conductivity is increased, better conductivity. This is about the N-type semiconductors. N-type semiconductors. So N-type semiconductor means that fourth group elements of silicon or germanium crystals to this crystal lattice when we add the impurity or pentavalent element. Mean after addition of pentavalent element, the surplus electrons mean this one is act as this conductor is act as a electron donor. So mean that is the electron surplus of electron easily jump to the valence band to conduction band. So it is very active. Mean that's good conductor. Mean that better conduct current than the pure semiconductors. This is about the N-type semiconductors. Okay. Now, p-type semiconductors. Okay, in p-type semiconductors. So, what is the p-type semiconductors? Just we have to take that p-type semiconductor. Mean it's an electron deficient. What is the electron deficient? Mean same silicon or germanium. One same silicon or germanium, we take that deficient molecule, group third molecule we have to take. What is that? Group third. That is the boron. In that, how many is there? This is the third group element. Third group element. In this, what happened? How many electrons are there? There are only 3 valency electrons. 3 valence electrons. One is shared with other silicon, here silicon and silicon. But there is no electron with sharing of a pair of electron to the one silicon electron. Here what happened? That hole is there. What? Hole. The hole is created. This is called the what? Positive hole. We can say positive hole. Positive hole. The positive hole created in p-type semiconductor. What is that? In p-type semiconductor. In p-type semiconductors, same. We have to take the silicon or germanium crystals. When this is the fourth group element, valence is the 4 valence, and where is the add the boron molecule, boron atom. So the three electrons are shared with the 3 silicon molecule, and another there is no electron, here the hole created. This is the positive hole. Okay, this is the structure of p-type semiconductor. Okay, I will tell you the difference between the n-type and p-type. What is that? In p-type we have added the boron, in n-type phosphorus as an impurity, and that is an excess electron, that is a freely moving electron. But whereas here the boron, only deficient molecule, the third group element, only 3 electrons are there, that is a great positive. Once again listen, when a group 4 semiconductor is doped with p-type trivalent group, that is such as boron, which has a less valence electron, than the semiconductor. Mean 4 are not there, only 3 electrons are there. The dopant acts as an electron acceptor. Here we can say electron acceptor. Electron acceptor. When few atoms of trivalent dopant replace the silicon atoms in a crystal lattice, a vacant state electron, this is the vacant one, is created and can act as an electron carrier through the structure, which creates the p-type semiconductors. So this one is create the p-type semiconductors. Okay, p-type semiconductors are characterized by a deficit of electrons and positive holes, which have the same effect as surplus of positive charge. Same, this is equal to the electrons. These positive holes accept electrons and rendering the semiconductors more effective at conducting current. More effective. This is about the p-type conductors. Okay, so what are the topics today we have discussed? Doping. Once again listen. Doping. Doping is nothing but the impurity. That is impurity. Impurity means that one small quantity of another element, small quantity of element. What is the definition? What I told you the definition? What is the doping? the doping means addition of small quantities of an element or impurity to a pure semiconductor, to change its electrical conductivity characteristics. That is the doping. Okay, and there are two types of dopings are there: n-type doping and p-type doping. So n-type doping is what? Movement of additional electron. P-type doping is the just creates the positively charged holes. Okay, that is the difference two things. And in n-type semiconductors, just what type of dopant added? Main crystal or germanium molecule. We add the phosphorus or arsenic pentavalent. We added. So silicon is the fourth group element, and phosphorus is the fifth group element. In silicon containing the 4 valence electron, and whereas the phosphorus containing the 5 valence electrons. Okay, mean here the dopant behave as an electron donor. Okay, this is the main extra electrons. When add the electrons, creates the main surplus electrons. Okay, this is about the n-type semiconductors. And p-type semiconductors mean in this water, in crystals or germanium or silicon, so we remove some crystal and add the third group element, mean that third trivalent, we can say trivalent dopant. In like boron, we have to use the boron, which has an less valence than the silicon. Means silicon is having the 4 valence and boron is having the 3 valence. Mean, so 3 atoms shared with the 3 electrons of boron with silicon, then one is vacant. So that one, the vacant state, mean creates the electron volt, is created and act as an electron carrier through the structure, throughout the structure, and which is create the p-type semiconductors. So this is about the story of n-type p-type semiconductors. Okay, so this is the last topic, and what are the topics we completed? So types of orbitals in this unit, linear combination, and molecular orbitals levels of nitrogen, oxygen and fluorine, and pi electron, pi bond, 1,3-butadiene, that is a pi molecular orbitals, and crystal field theory. So then semiconductors and types of band structures, mean band theory, and then semiconductors. So these are the whole topics. This lesson is a very small lesson and very, very important, and we will get a good marks in this unit. Okay, thank you.